I'd like to say something about percentiles. We've already learned about one percentile of the data, and that's the median. It splits the data in such a way that 50% of the cases are below the median, 50% are above the median. Now, in a similar way, we could say we're not interested in a 50% split, but let's say we're interested in a 25% split. And in that case, we can use the function percentile. We need to say which data we want to use for that purpose, and we need to give this number k here, which is the percentage split. So the result of 128,000 says that 25% of the cases in this data set have a price below 128, and the remaining 75% have a price above 128. Important thing is a percentile requires the data and that percentage. The result is a number in the units of the original data, so dollars in this case. Now, in the same way, we could come up with other percentiles like 75% or 10% or 90% and see what comes out, and we find again that median here, 50% of the cases below 159, or 90% of the cases are below a price of 275 approximately, and the remaining 10% are above that. Note that computation that we do here does not require any assumption about the data, but we could use an assumption, like we could say what is the corresponding percentile if we assume that the data is normally distributed. And in that case, we can use the function norm inverse. This is the equivalent to a percentile, but this time assuming a normal distribution. So what we need to provide is a probability, and as we know from a normal distribution, it's completely characterized in terms of mean and standard deviation. And we get a price of about 84,000, which means that 10% of the cases are expected to be below 84,000, assuming a normal distribution. Whereas about $100,000 is the price for which we find about 10% below in that particular sample. So computing those normal percentiles for the remaining probabilities and percentages, we find the mean here, of course. And again, comparing the median to the mean, the median has the advantage that it is a robust measure. It's not affected by the extremes, simply because it's based on the number of cases and not on the actual values of the cases like the mean. So if in this particular data set there is some rather large numbers included, that would make the mean reflecting that and become larger, whereas the median does not respond in the same way.